Hello everybody, welcome to the video lecture schedule of Operations Research. Today we will start the new section, that is transportation problem. Now at first I am giving the content of this lecture. So at first I will introduce the transportation problem, then I will give the solution procedure of the transportation problem, and then introduce several methods of the solution, in how many methods we can solve the transportation problem, which are included into our syllabus, and then I will give an example. So at first I am giving the introduction. The transportation problem is one type of linear programming problem, but it has own method, own procedure to solve the problem, which is totally different from the simplex method. Now in this method we are transporting some commodity from some origin to some destination. So the transporting cost will be given, and in this method our aim is to minimize the transporting cost from different origin to different destination. Now at first the capacity of each origin will be given and the demand of each destination will be given, and the cost of transportation will be given in the problem. After solution, we will find how many units will be given from one origin to another destination, and then we will find the corresponding cost of the transportation problem, and then at last we will find the minimum cost of the transportation problem. Now a transportation problem is basically given in a table. So here how many origins are there? The origins are, m number of origins are there, O1, O2, O3, OM, and how many destinations are there? D1, D2, Dn number of destinations. So n number of destination and m number of origins are there. M and n may be equal, may not be equal. It does not matter. And the available unit of each origin will be given, that is, in the origin O1, the available unit is A1. In the origin O2, the available unit is O2. In the origin O3, the available unit is A3. And similarly, in the origin OM, the available unit is AM. And in the corresponding to the destination D1, the requirement unit are given by, in the destination D1, the requirement unit is B1. In the destination D2, requirement unit is B2. Similarly, in the destination Dn, the requirement unit is Bn. Always the requirement unit is given by Bj and the available unit is given by Ai. And here, in the matrix, Cij are given. Cij means C of 1, 1. That means this is the transporting cost if we supply one unit from origin O1 to destination D1, then the corresponding cost is C11. If we supply one unit from origin O1 to destination D2, the corresponding cost is C12. Similarly, if we supply one unit from origin O2 to destination D2, the corresponding cost is C22, and similarly other. And so, if we supply one unit from origin OM to destination Dn, the corresponding cost is given by Cmn. So, in the transportation problem, the transporting cost is given, the available unit of each origin and the requirement unit of each destination will be given. There are several procedures to solve this transportation problem. Then after solving this transportation problem, we will find the number of unit. How many unit will be transferred from one origin to different destination. And then we will find the corresponding cost. At first we will find the corresponding cost of this method. So how many origins are there? M number of origins are there, which are denoted by OI, and I is equal to 1 to dot 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 M, and at each origin the corresponding available unit are given by AI. And how many destinations are there? N number of destinations are there, that is denoted by DJ. So J is equal to 1 to dot 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 N, and the corresponding requirement unit are given by Vj. So J is equal to 1 to dot 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 N. Already all the things are described, and the quantity, obviously the quantity AI and Bj are always non-negative. Now the sufficient condition for the transportation problem is summation of AI will be equal to summation of Bj. That means total number of available unit will be equal to the total number of requirement unit. Then the transportation problem is called balanced transportation problem, and then only we can solve the transportation problem. If summation of AI is not equal to summation of Bj, then the transportation problem is called unbalanced transportation problem. Then at first we have to balance it, and then we can solve this transportation problem. And Cij is the corresponding transporting cost from the ith origin to the jth destination. Now what is the solution? Suppose we are supplying x11 unit from origin O1 to destination D1. That is why I have written here x11. We are supplying x12 unit from origin O1 to destination D2. So I have written here x12. Similarly other. So suppose we are supplying OM origin to DM destination, the number of unit is xmn. So xij is the number of unit which is supplied from ith origin to jth destination. Since in the O1 origin we supply x11 unit, x12 unit, dot 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 x1n unit, and the corresponding available unit in this origin is A1. So obviously x11 plus x12 plus x1n will be equal to A1. Similarly x21 x21 plus x22 plus dot 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 plus x2n will be equal to A2. Similarly other xm1 plus xm2 plus xmn will be equal to am. Similarly the requirement unit of the destination is B1. So obviously if we add all the unit which is supplied in the destination D1 will be equal to B1, that is x11 plus x21 plus x31 plus dot 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 plus xm1 will be equal to B1. Similarly x1n plus x2n plus x3n plus dot 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 plus xmn will be equal to Bn. So obviously xij will be greater equal to 0. So either we cannot supply any unit to any destination, or we have to supply a positive number of unit, because the number of unit cannot be negative. So obviously summation of xij, summation will be over j will be equal to ai, and summation of xij, summation over I will be equal to bj. Now there are several solutions of this transportation problem. And what is our aim? Our aim is to minimize the cost. And what is the corresponding cost? Since we are supplying x11 unit from O1 origin to D1 destination, so the corresponding cost of that cell is C11 into x11. Similarly, since we are supplying x12 unit from O1 origin to D2 destination, and the corresponding cost is C12, therefore the corresponding cost is C12 into x12. similarly other. Therefore, what is the total cost? The total cost is C11 into X11 plus C12 into X12 plus dot 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 plus Cmn into Xmn, which is given by some double summation. One is over I, another is over j, Cij into Xij. And what is our aim? Our aim is to minimize the cost. Obviously, always we want to minimize the cost. Now, there are several procedures to solve this transportation problem. We can solve the transportation problem by northwest corner method, then matrix minima method, and then Vogel's approximation method. These are included into our syllabus. So at first, we will solve a problem with the help of the northwest corner method. So here, a problem is given. So how many origin are there? 3 origin are there, O1, O2, O3. And how many destination are there? 4 destination are there, D1, D2, D3 and D4. And what is the available unit of each origin, which is given by AI? So available unit of the origin O1 is 7, available unit of the origin O2 is 9, and available unit of the origin O3 is 18. And what are the requirement unit for the different destination? For the destination D1, requirement unit is 5. For the destination D2, requirement unit is 8. For the destination D3, requirement unit is 7. And for the destination D4, requirement unit is 14. So at first, we have to check whether this transportation problem is balanced transportation problem or unbalanced transportation problem. Because if the problem is unbalanced transportation problem, then we cannot solve. At first, we have to make it balanced transportation problem. Then only we can solve the transportation problem. So what is the procedure? We have to find summation of AI and we have to find summation of Bj. So what is the value of the summation of AI? 7 plus 9 plus 18. So 7 plus 9 16. 16 plus 8 24 plus 1 34. So summation of AI equal to 34. And what is the value of summation of Bj? 5 plus 8 13 plus 7 20 plus 14 34. So we are finding here summation of AI is equal to summation of Bj. Therefore, the given transportation problem is a balanced transportation problem. Now, we have to solve this transportation problem by northwest corner method. So, what is the northwest corner method? Suppose this is the north, and then if it is the north, then this is the west. So, in this cell, the diagonally upward cell, this cell is called the northwest corner cell. So, in this matrix, which one is the northwest corner cell? O1, D1 is the northwest corner cell. So, at first, we have to allot in this cell. We have to allot in this cell, O1, D1, because this is the northwest corner cell. Then, according to the fulfillment of the origin requirement or destination requirement, the next northwest corner cell will be chosen. So, what is the corresponding available unit of this cell? The corresponding available unit is 7, because this is in the O1 origin. This cell is also present in the O1 origin. Corresponding available unit is 7. And what is the requirement unit in this cell? The corresponding destination is D1 and the corresponding requirement unit is 5. So, corresponding requirement unit is 5 and the available unit is 7. So, 5 unit is required and 7 unit is available in this origin. So, we can supply only the minimum of 5 and 7, because if we supply more than the requirement unit, then it will be destroyed. So, the cost will be minimized, cost will be maximized. That's why always we will supply the whatever is minimum among the available unit and the requirement unit, that will be supplied in that cell. So among 5 and 7, which one is minimum? 5 is minimum. So we will supply 5 unit in the cell 19. We will supply 5 unit in this cell. So since we are supplying 5 unit in this cell, so which requirement is fulfilled? O1 or D1? Because here we are supplying 5. So till now here how many available unit is present? 7 minus 5, that is 2. So requirement of O1 origin is not fulfilled. But requirement of the D1 destination is fulfilled or not? Yes, it is fulfilled, because in the D1 destination we can supply 5 unit because it is required, and already we have supplied 5 unit in this cell. So requirement of D1 destination will be satisfied. So then we cannot supply any other unit in this destination, in any other cell, because we cannot supply any unit in the cell 70, we cannot supply any unit in the cell having 40, because if we supply some element, suppose one element, then in this destination the element will supplied element will be 5 plus 1, that is 6, but the requirement unit is 5. So we cannot supply more unit in this destination. So now what is the corresponding northwest corner cell? Then the corresponding northwest corner cell is 20. In this way we will, then we have to allot in this cell. Then we have to allot the cell 20. And then if we allot in this cell, then what is the corresponding available unit? 7 minus 5, that is 2, and the corresponding requirement unit in this destination is 8. Which one is minimum? 2 and 8, that is 2. So we can supply 2. So that now the requirement of the origin O1 will be satisfied, and this one will be decreased, and it will be 8 minus 2, that is 6. So now after supplying 2 unit in the cell O1 D2, then the northwest corner cell will be O2 D2. In this way we can supply the unit in different cell. So here all the procedure are given. So at first O1 D1 is the northwest corner cell, and what is the corresponding available unit in the O1 origin? 7. And what is the requirement unit in the destination D1? That is 5. So which one is minimum among 5 and 7? That is 5. So we can supply 5 unit in the cell O1 D1. Now when we are supplying 5 unit in the cell O1 D1, so D1 column requirement is fulfilled, and the available unit in the O1 origin will be 7 minus 5, that is equal to 2. Now which one is the northwest corner cell? Now O1 D2 is the northwest corner cell, and what is the available unit in the O1 origin? That is 2 unit. And what is the requirement unit in the D2 destination? That is 8 unit. So which one is minimum? 2 is minimum among 2 and 8. So we can supply 2 unit in the cell O1, in the cell O1 D2. We can supply 2 unit in the cell O1 D2. So we can supply 2 unit in the cell O1 D2, and then the requirement of the O1 origin is fulfilled. So O1 origin will be discarded, and which one is the next northwest corner cell? The next northwest corner cell will be O2 D2. And what is the corresponding available unit in the origin O2? That is 6 unit. And so we have to allot 6 unit in the cell O2 D2. As the requirement unit in the D2 destination is 8, and already 2 unit is given to the cell O1 D2. So what is the available? So 8 minus 2, that is equal to 6 unit is available. Now the northwest, now in the next table the northwest cell will be O2 D3. So we have to allot 3 unit in the cell O2 D3. Now the O2 origin requirement is fulfilled. So what is the next northwest corner cell? The next northwest corner cell will be O3 D3. Next northwest corner cell is O3 D3. O3 D3, because we are supplying 3 units here. So it is fulfilled. 6 plus 3 equal to 9, it is fulfilled. So it is also now will be discarded. So what is the corresponding origin available, that is O3, and what is the destination? What are the destination at present? D3 and D4. Now in the destination D3, 7 units are required. Already we supply 3 units in the cell O2 D3. So now the available unit is 4. So we are supplying 4 units in the cell O3 D3. And what is remaining? This column requirement is fulfilled. 3 plus 4 equal to 7. Now what is the remaining available unit in the origin O3? 18 unit. It was 18 unit at first. Now 4 unit is supplied. So the remaining unit is 14. So 14 will be supplied in this cell. And obviously here in the D4 destination, the requirement unit is 14. Now we have to check whether we have done wrong or not. So 5 plus 2, because summation of xij, summation over j will be equal to ai, and summation of xij, summation over I will be equal to bj. So 5 plus 2 equal to 7, 6 plus 3 equal to 9, 4 plus 14 equal to 18, then 5, 2 plus 6 equal to 8, 3 plus 4 equal to 7, and here it is 14. So we have done right. So what is the corresponding solution of this transportation problem by northwest corner method? So x11 is equal to 5, x12 is equal to 2, x22 equal to 6, x23 equal to 3, x33 equal to 4, x34 equal to 14. And what is the corresponding cost? If we multiply, because if we supply 1 unit from one origin to D1 destination, the corresponding cost is 19. Now we are supplying 5 units. So what is the corresponding cost? 5 into 19. Similarly, we will multiply this element 6 into 30, 3 into 40, 4 into 70, and 14 into 20. And we will add all these value. So what is the corresponding cost? We are multiplying this value. So after solving this, we are getting 995. So what is the corresponding cost? This is corresponding cost. This is not the minimum cost, because after this we have to do some other technique. We have to apply some other technique to find the minimum cost. At first we will describe all the method, then we will describe the optimality test, and we will find the minimum cost. So what is the corresponding cost? Now this is the corresponding cost. So the corresponding cost is 995. And this solution is called initial basic feasible solution, because this is the initial solution. This solution is called the initial basic feasible solution of this transportation problem. And the corresponding cost, not the minimum cost, and the corresponding cost is 995. So today what we learn? We learn what is transportation problem, what are the several methods of the transportation problem, and among them one of the method is northwest corner method, and then we learn how to solve the northwest corner method, and what is the initial basic feasible solution, and what is the corresponding cost of the transportation problem by northwest corner method, not by the other method. Because if we apply the other method, the initial basic feasible solution may be different, may not be different. So when we are applying the northwest corner method, then this is the initial basic feasible solution, and the corresponding cost is given by 995. Thank you.